All right, so let's talk about some general results about the absolute value function. Result one, the mod of x squared is equal to x squared. The mod of x squared is equal to x squared. So later on we'll look at examples requiring this knowledge, or how examples demonstrating how this knowledge could be useful. Result two, the mod of xy is equal to the mod of x multiplied by the mod of y. So the modulus of a product is equal to the product of the modulus. Result three, the mod of x over y is equal to mod x divided by mod y. So the modulus of a quotient is equal to the quotient of the moduli. Result four says, given that c is a constant, so c is a constant, and the mod of x is less than c, the mod of x is less than c if and only if x is less than c and x is greater than minus c. So this means that for any constant c, the modulus of x is less than c if x lies between c and negative c. All right, so this is a result. This result in particular, you need to be able, if necessary, to reproduce it for yourself. So, for example, the mod of x is less than c. I could say that x is less than c, or minus x is less than c. And so x is less than c, or x is greater than minus c. So x is less than c, and at the same time, so x is less than c, and at the same time, x is greater than minus c. So in other words, if x is less than c, or x is less than c, sorry, the mod of x is less than c, if and only if x is less than c or greater than minus c. All right, so as I said, these are results that, if necessary, some of them, you need to be able to derive them for yourself. Result 5 says, given a constant c, the mod of x is greater than c if and only if x is greater than c or x is less than minus c. Again, that's a result that you could come across for yourself. Result 6 says, the mod of x is less than the mod of y if and only if x squared is less than y squared. So the modulus of x is less than the modulus of y if and only if x squared is less than y squared. Now, since the mod of x is less than the mod of y, therefore the mod of x squared must be less than the mod of y squared. And so, because the mod of x is positive, the mod of y is positive. So if the mod of x is less than the mod of y, the mod of x squared must be less than the mod of y squared. And then using result 1, we can see that x squared must be less than y squared. So the mod of x is less than the mod of y if and only if x squared is less than y squared. So I'm going to do example 15 next. And example 15 utilizing result 1. Now, result 1 essentially is the mod of x squared is equal to x squared. That's result 1. So example 15, we have done questions like example 15 already, but we're going to do example 15 using result 1. Now, the mod of 2x minus 1 is equal to 3. Using result 1, it means that the mod of 2x minus 1 square is equal to 3 square. Now, I think the mod of 2x minus 1 square is the same as saying 2x minus 1 square is equal to 3 square, which is, so let's just say 3 square for now. Simplifying, expanding the left, we have 4x square minus 4x plus 1 is equal to 9. Now this becomes a quadratic equation. Let's solve. We have 4x squared minus 4x plus 1 minus 9 is equal to 0. 4x squared minus 4x minus 8 is equal to 0. Dividing the entire equation by 4, we get x squared minus x minus 2 is equal to 0. Factorizing, we have x here, 2 here, 1 here, negative here, plus here. So now we have x plus 1 is equal to 0, or x minus 2 is equal to 0. Therefore, x is equal to minus 1, or x is equal to 2 are the solutions for example 15. All right, example 16. Now, example 16, using result 1. Result 1 essentially says that the mod of x squared is equal to x squared. So if I have the equation, the mod of 2x minus 3 is equal to the mod of 4x minus 1. Using result 1, I would start by squaring both sides. So using results 1, this would be 2x minus 3 squared, because the mod of x squared is equal to x squared. So the mod of 2x minus 3 squared is equal to 2x minus 3 squared. And the mod of 4x minus 1 squared is equal to 4x minus 1 squared. Squaring both sides, I get 4x squared minus 12x plus 9 is equal to 16x squared minus 8x plus 1. Let's get all the x's to one side. Let's make one side be 0. We have 16x squared minus 4x squared minus 8x plus 12x plus 1 minus 9 is equal to 0. So now we end up with what? 12x squared plus 4x minus 8 is equal to 0. Dividing the entire equation by 4, we get 3x squared plus x minus 2 is equal to 0. So next, let's factorize. Yeah, man, we should be able to factorize. All right, so we have 3x, x, 2, or is it 1 there? So 1 plus 2 minus is equal to 0. And so 3x minus 2 is equal to 0, or x plus 1 is equal to 0. Therefore, x is equal to 2 over 3, or x is equal to minus 1 are the solutions.